Good afternoon. I'm Gary Feyereisen, an adjunct assistant professor in the department and a research agricultural engineer with ARS. My office is in the Uber basement of Borlaug Hall with my team, Todd Schumacher, ARS technician, who's here. Hassan Ghani is a postdoc who will be leaving us at the end of the semester, or at the end of the year, to go to Michigan State. And Dr. Josh Campbell, who's also in the room, ARS researcher that we brought on in May. Marta Roser was a student who finished and got a job. That's very encouraging. And we always have one or two undergrad students. Right now we have Carter Swears, who started last week and remains unphotographed. My research includes biofiltration processes and design. Also, a lot of what I do has reducing tile drainage nutrient losses in the objective. I enjoy modeling because it brings all the interconnections of soil, plant, atmosphere together. My passion is to see the natural elements used to feed people, both here and abroad. I've been to Africa a few times and really enjoy it. One of my passions is to see sufficiency on that continent. I love to mentor students, call them the next gen researchers. At my stage, my impact will last only so long, but they'll go on for decades. I also love numbers and data, science and theology, and the greatest thrill that I have in my work is seeing my work get other people excited about their work. My near-term goals include working on Minnesota's water quality. Also, I've made some connections with people in Europe at the International Drainage Symposium held last month. I hope to follow up with them. Eventually, I'd really like to mentor young researchers in developing countries. My current work includes a lot having to do with denitrifying bioreactors around the state. Here in St. Paul, we've run a couple of column experiments and found that if we add a soluble carbon source to the denitrifying bioreactor, we can immensely improve the nitrate removal rate at cold temperatures. I mean, just a few degrees above freezing. We've taken that learning out to the field near Wilmer on a regular bed-style bioreactor, and as we speak, this experiment's going on with the biostimulation, also with bioaugmentation. We're also, this is really a cool thing, Jeff talked about it earlier, but as a result of brainstorming of the PIs involved with this project, we come up with a pretty unique way to remove nitrogen, and we're looking at phosphorus too. That experiment's being done out in Lamberton. And finally, there's another really interesting bioreactor that we've just instrumented this year. This one's an attempt to treat more water. Basically, the flow comes into the first cell and out. And as the hydrograph comes up, the flow will pass, then overflow to the next cell, and finally to the third cell. The idea is to treat more water and to keep the first one. Bioreactor is like a calf's belly. It's microbes, right? You want to keep it going at the same temperature and the same flow rate if possible. The idea is, can we treat more water? Ooh, that went too fast. All right. Basically, if we add up these three cells, we see they can treat the base flow pretty fine. Tomasz, you're probably interested in this. But what happens when the peak comes? And the peaks are coming. I didn't mention, this is a result of a 3-inch rain in southern Minnesota last night. This is fresh off the press. Finally, we are doing quite a bit in dairy. We have nearly a decade of soil, water, and gas exchange measurements. Published a paper on that. Josh is working on the soil carbon effect of this system, which is silage, corn, and alfalfa, with manure coming back to provide nitrogen for the system. Also, we're involved in a multi-ARS location thing, the Dairy Agro Ecosystem Working Group, where we're trying to reduce by 20% reactive N losses in the dairy industry, and finally, working on manurial nutrient release.